Hello बच्चों, in this video we will study about displacement reaction and double displacement reaction. The link of the previous video on types of reaction part 1 where I have explained combination and decomposition reaction is at the top right corner. You can click on the link and learn about combination and decomposition reaction from there. So let's get started. Displacement reaction. Displacement reaction, as the name suggests, in these reaction, one element displaces the other element from its compound. Let's see the definition. When a more reactive element displaces a less reactive element, more reactive element displaces a less reactive element from its compound, the reaction is called displacement reaction. Let's see the example to make you understand. The first example here is lead. This is lead, which is gray in color. S solid, it is in solid state. And here copper sulfate, aqueous. AQ means aqueous. That means copper sulfate crystals are dissolved in water. The solution is blue in color. Now, when lead is added to copper sulfate solution, the reaction takes place and what do we get as product? We get lead sulfate and copper metal. Now this lead sulfate is white in color and it is insoluble in water. This is insoluble in water. Since it is insoluble, it will not dissolve in water. It will settle at the bottom of the test tube or the beaker in which we are doing the experiment. Here, this arrow here pointing downward shows that it will settle at the bottom. Okay. So we call it a precipitate. Precipitate. Now, which is abbreviated as PPT. Okay, this PPT is different from the PPT which we make in computer. So this is precipitate for in chemistry. Now copper metal. Now this copper metal will be, it is reddish brown in color. So we'll see particle of copper in the beaker along with this lead sulfate. Now we can see lead has displaced copper from its compound and taken its place and has formed lead sulfate. So this lead is a more reactive element as compared to copper, which is less reactive. So lead is more reactive and copper is less reactive. That is why lead is able to displace copper from its compound and form lead sulfate. Now let's see the next example. Iron, again solid, we can take iron nail, iron filing, we can take piece of iron, anything, okay. And then again copper sulfate, which is again blue in color. What is the color of iron? Iron is also gray, it is silvery gray. It's quite shiny, okay, pure iron. Now iron metal, when it is added to copper sulfate solution, again aqueous dissolved in water, which is blue solution is added, again you can see FeSO4 is formed. Now iron is more reactive as compared to copper. So it displaces copper from its compound and forms iron sulfate. You can see in bracket I've written aqueous. That means it doesn't precipitate out. It will remain dissolved in water. The color of the solution will become now pale green. Pale green. And copper metal, again reddish brown particles of copper will be seen at the bottom of the test tube as well as on iron nail. If you are taking iron nail, piece of iron, on that you'll see the deposit of copper, reddish brown in color. Now here you can see the color of the solution changes from blue to pale green due to the formation of iron sulfate. So this is a very common reaction, children. This reaction I'll perform in the form of short. I'll upload it on my page. You people can see after 2-3 days. I'll put the link here also on this page. You can click and see that reaction. So this is displacement reaction. Again, we'll read the definition. I hope you have understood. When a more reactive element displaces a less reactive element from its compound, the reaction is called displacement reaction. Okay. Now let's look at this reactivity series of metals. It is also known as activity series, children. Metals have been arranged in order of their decreasing activity. After performing displacement experiment with various metals and compound, the following series has been developed. Metal at the top of the series are most reactive, and at the bottom of the series is less reactive. Here you can see hydrogen also in this reactivity series of metal. Why hydrogen has been placed in this reactivity series of metal? The reason is that like metal, hydrogen also has tendency of losing electron and form positive ion. Okay, so hydrogen has been placed here, and now let's see the importance of hydrogen here. The metals which lose electron less readily, okay, than hydrogen are placed below hydrogen, okay, and the metals which lose electron more readily as compared to hydrogen, okay, more readily means faster than hydrogen, okay, they lose electron faster than hydrogen, are placed above hydrogen in this reactivity series, okay, they have been placed above hydrogen. Now, the reactivity series goes potassium, the most reactive, sodium, calcium, magnesium, aluminium, zinc, iron, lead. These are more reactive than hydrogen, and metals like copper, mercury, silver, gold being the least reactive, have been placed below hydrogen. Now children, we move on with double displacement reaction. In double displacement reaction, two different atoms or groups of atoms displace other atoms or group of atoms. Let's understand it better with the definition. Reaction in which there is exchange of ions. An exchange of ion between the reactant are called double displacement reaction. Let's see example and understand it better. Okay, now you see the first example, barium chloride. Barium chloride, it is in aqueous, in bracket I have written AQ, that means it is dissolved, the salt is dissolved in water. After dissolving we get a colorless solution. Okay, this is barium chloride in aqueous state. Okay, sodium sulfate when dissolved in water, this is also colorless. When these two, if we take these two in two different test tubes, both are colorless. Okay, both you'll see they'll be colorless. Now, when we mix barium chloride to sodium sulfate, okay, we will see immediately white precipitate. You know very well what is precipitate now. This arrow shows the precipitate will settle at the bottom. This is white precipitate of what? Barium sulfate will be formed. Okay, and sodium chloride, another product will be formed, which is in the aqueous state. I have written in bracket AQ, that means it will be in solution. Okay, so it is also colorless, sodium chloride solution. Okay, now exchange of ion, in the definition I have written exchange of ion. Let's break the compounds into ions. We get barium chloride Ba and Cl. Okay, barium chloride, barium ion and chloride ion. Sodium sulfate, in the next slide I'll show you the ions also properly. Okay, sodium ion and sulfate ion. Simply here you understand. Now exchange. Barium takes place of sodium, and sodium goes and takes barium's place. Okay, so there is exchange of ions. So what is formed as a result? Barium sulfate is formed which is a white precipitate, and sodium chloride is formed, which remains in solution. Okay. Now let's see the next example, children. Silver nitrate. Again, we can break this into ions, silver ion and nitrate ion, potassium iodide ion, potassium ion and iodide ion. Now again there is exchange. You can see, you can do it on your own even. Let me take a darker color. Silver ions take, these are positive ions, I'll show you in the next slide. Silver ion takes place of potassium ion, and what potassium does? Potassium goes and takes silver ion's place. Okay. So as a result, we get silver iodide. Okay. Here in this slide, this is L, it should be S. Okay. Solid. So silver iodide, which is again a precipitate, it is yellowish in color. Okay. It is yellow precipitate, and it will also settle at the bottom of the test tube, and silver nitrate will remain in aqueous form. It will be in solution. Okay. So this is exchange of ion is taking place. It's very clear. Silver ion goes and takes potassium ion's place, and potassium ion, they go and take silver ion's place. Okay. Let's see in the next slide with the help of ions. Okay. So exchange of ion is already written here. Let's understand it better with the help of ions. Barium ion. Okay. So we have 2 plus chloride ion. Okay. Is this sodium ion? I'll write with green. Sodium ion and sulfate ion. Okay. So you can see, children, barium chloride is positive ion, barium ion, and chloride ion, negative ion. Okay. An ion. Here sodium ion, positive ion, okay, cation, and sulfate ion, anion, negative ion. Now what happens, I told you in the previous slide, barium. So when we do this reaction, double displacement reaction is done in aqueous state. Okay, it is dissolved. The salts are dissolved in water. So when the salts are dissolved in water, they dissociate to form ions. Okay, you can see the ions here. So these ions cannot remain as such as in the form of ion. They have to combine to become stable. So barium takes place of sodium, and sodium goes and takes whose place? Barium's place. Okay. So as a result, barium sulfate and sodium chloride are formed. Here also you can break them in the form of ion. You'll get positive ion of barium, sulfate, negative ion. Okay, cation and ion, they combine together and form the salt. Here also sodium ion and chloride ion, positive and negative ion, they combine and become salt. Okay. Similarly, you can do it here, children. Silver ion and nitrate ion. I'll write the ion, exchange of ion. You write it in your notebook and do it. Okay. I'll just break them into ions. Silver ion and nitrate ion. Okay. Then for potassium and iodide ion. So now think and write how the exchange has taken place. Here there's a correction. This should be S. Since it settles at the bottom, it is in the solid state. Okay, children. So this is how exchange of ion takes place in double displacement reaction. I have explained you. I hope it is clear. Practice with more examples given in your book. Okay. And if there is any doubt, you may write it in the comment, children. So with this, we finish displacement reaction and double displacement reaction. Thank you for watching. Please do like, share and subscribe the channel. Bye bye for now. Happy learning.